Circle geometry rider number 5. Of course, we're going to the reminder first that we have circle geometry strategies, a video in this series at that address. A reminder from that video: when doing geometric riders or proofs, know your theorems. That goes without saying. Don't wait for the geometry to come to you. You need to ask questions, as you'll see in my thought processes. Start with what you're finding or proving and work from there. Don't just draw on everything equal that you can see in the diagram. You can only confuse yourself. If proving two angles equal, take one and find what it is equal to or what it combines with. And if proving something about lines or shapes, parallel lines, cyclic quads, whatever, ask what if it is so. So there's rider number 5. We have a circle, we have these two tangents. I remind you that those are tangents from a common point and therefore they're equal to one another. And we have a pair of parallel lines. So we first have to prove that AC bisects PAD, or in other words, A3 and 4 equals A2. So we're going to go straight into take one angle. We're not going to go into what if it is so. Don't say what if it is so normally for proving angles equal. It's only for lines and shapes. So let's take one of them. What is A2 equal to? And there's a big hint in blue there in the diagram. A2 equals C1 and 2, alternate angles and the parallel lines. So now we ask, is C1 and 2 equal to A3 and 4? What I'm trying to prove A2 equal to. And the answer is yes, of course. There's the hint in red. Tangents from a common point. So that makes the angles that we're trying to prove equal to one another. So let's go to our formal proof. Step 1. A2 equals C1 and 2. Remember, that's part of our thought process, alternate angles, and we state the parallel lines. Then I'm going to say, well, I need to say C1 and 2 equals A3 and 4. That equals A3 and 4, but I'm just putting this in first because the theorem tangents from a common point says the lines are equal, not the angles there are equal. So let's just put that first, and then we can just use that being an isosceles triangle. And therefore we have A3 and 4 equal to A2. I don't have to write therefore AC bisects PAD. I've said it in a slightly different way, that's all. Part 2. Prove that B1 equals B3. Now notice that I've divided it into two parts because I've seen immediately that I think I'm probably going to say that this angle is equal as an exterior angle of a triangle. I'm going to go that way. So, take one angle. So I'm going to take B1 and say, what is B1 equal to? And there's the hint in blue. It's equal to those two. Exterior angle triangle. Now I'm going to go to the other one, B3, and I'm going to say, well, what is it equal to? And there's your hint in red, pink, whichever you prefer. It's equal to D, exterior angle cyclic quad. So we have that equal to those two and this equal to that. So ultimately I'm going to prove that these two equals that. So I'll break it down. We have B1 equaling P2 and C1. I have B3 equaling D, which is D1 and D2. Now if you have a look, we have D1 and D2 equal to one another because of the parallel lines. Notice the green situation with alternate angles and parallel lines. And we have C1 and D2 equal to one another because, have a look at the green lines, it's tan chord, tangent, chord, angle subtended in the alternate segment. So therefore that makes that angle equal to this angle here. And it makes the ones we're trying to prove equal to one another. So my proof, B1, P2 plus C1, so this equals those two. Now I'm going to break it up. I'm going to say, well, B3 equals D1 and 2, but P2, I'm having an argument with somebody, P2 equals D1, alternate angle, parallel lines, and C1 equals D2, tan chord. So I've said that equals that, that equals that, those are equal, therefore B1 and B3 must be equal to one another. Next part of the proof. We have to prove APC equals ABD. There they are marked with a little double red line. So our thought process, we're going to go straight back and to take one. We're going to take one of them. And always try to be logical. In other words, take one that you think might be equal to other things. For example, this one would be acceptable because we could go to a corresponding angle. This one may be acceptable because we can go to angles in the same segment, but I think I'm going to go for P1 and 2. What is APC equal to? And there's your hint. In pink, in red. Yes, corresponding angles is equal to A1, corresponding angles and parallel lines. Now, what is A1 equal to? So we've got P1 and 2 equal to A1. Now we say, well, what is A1 equal to? Or is A1 equal to B2? Because I'm trying to prove this P equal to B2. I've got that P equal to A1. Is A1 equal to B2? And there's a big hint in green. Yes, tan chord. So therefore we have those angles equal. Let's go across to the proof now. So P1 and 2 equals A1, corresponding angles, parallel lines. Then we take the A1 and we say, well, that A1 is equal to B2, tan chord. So now we have P1 and 2 equals A1, which equals B2, which means we can say P1 and 2, there's P1 and 2 equals B2. Proven. The last part of this proof, let's write it. Prove A4 equal to P2. We're going to go straight to what is it equal to, and this one's going to be pretty straightforward here. In fact, really, we say what is P2 equal to? There's the hint in pink. Alternate angles AD parallel to BC. So that's D1. Now we're going to ask, is P2, is A4 equal to D1? We've got P2 equal to D1, so we need A4 equal to D1. The answer is yes, hint in pink, tan chord. So therefore we have those equal to one another. So back to the proof. P2 equals D1, alternate angles, parallel lines. D1 equals A4, tan chord. D1 equals A4, tan chord. And so we have P2 to D1, D1 to A4, which means P2 to A4. Proven.